this point of time. Again, you need to enable dump. Then only we can check the waveform. The variables will be dumped into the waveform. Okay, just check with the and dump all variables we can dump. And these are the examples for dollar monitor, dollar display, these things. And there are a lot of examples here. Just try from your side. Whatever I have explained till now, same simulator directives and system task. Another important concept in Verilog HDL is $random. So what is meant by $random? What is meant by $random?
It assigns the random data to the inputs.
Okay. In Verilog, we will just discuss about the $random, but in system Verilog, we have lot of ways, like methods to write the $random. We'll see in the system Verilog briefly, but in Verilog, I will just explain simply. So here you already know this example, multiplexer array model, right? So here, if you take $random means what? First of all, here 32-bit, 4-bit. 4-bit means okay, we can generate the data manually for input selection lines. Okay. Suppose if we write same for 32 by 1 multiplexer. 32 by 1 multiplexer means what? There will be 32 number of inputs, 5 selection lines and 1 output. So it is difficult to assign 32-bit data to inputs selection lines. We need to generate 32 number of selection lines always, right? So it is very difficult. Already we have tried using the always block for selection lines. We have generated for 5 selection lines. Okay, have you remembered that point we have generated with the always block 1, always block 2, always block 3. So like that we can generate, or else for loop. Okay, but in industry, we will work with a lot of scenarios, even lakhs of bins we need to write, lakhs of test cases we need to write. We need to verify every corner case scenario. Okay, but in that case, it's very difficult to generate the hardcore values. Here, every value we are using, we are just assigning manually. Okay, as a human being, we can assign 10 number of values or 20 number of values or even 100 number of values, but it takes a lot of time. Okay, but without assigning these hard coded values, we can directly use the $random. Okay, that means it just randomize and allocate the random values. Those random values will be differed from simulator to simulator. One simulator will generate some random value, other simulators will generate some other values, like that it differed. Okay, but $random means without assigning the manual values, hard coded values, we can automatically the simulator will do the randomization. Okay, see here, suppose data is there, data equal to, I am assigning $random and select is equal to $random. This is the syntax, and here also $random. So automatically do randomization and generate some random value and allocate the value. See here, data equal to 0, 1, 00, but we didn't assign any value for the data. It just randomized. Okay, and then select equal to 0, 1, 1, 1, 0, 1. Okay, so out equal to something. According to that value, we got the output. Like that, we can do the randomization. But by using Verilog randomization, we have lot of limitations. Okay, one major thing, if you see here, it didn't randomized properly. It just randomized 3 values. Okay, even in that 3 values, 2 are repeated values. 1 is generated 2 times and 3 is generated. 0 case and second case not generated. So 2 cases are wasted. Okay. It just generated only 3 times, but in that 3 also 2 are repeated. Okay. If there are repeated values, our number of scenarios will be wasted, right? Whatever the value it is generating, even it is repeated one time or even 100 times also will get same output. So no need to generate 100 number of times. Okay, so it is wastage. So that is one of the drawback in Verilog HDL. But in System Verilog, we have that limitation. We can overcome that limitation in System Verilog. Okay. Another thing, in Verilog HDL, we don't have the constraint topic. Constraint topic in the sense, it's a controllability on randomization. Okay. Suppose here multiplexer is a 4-bit size. In the same case, if you consider multiplexer as a 32-bit size, okay, in that 32-bit size, or else just consider a register memory, okay, 32-bit size memory. 32-bit size memory means there will be a 32-bit address and 32-bit data. Okay, so you are trying to store the data into the each memory location. Suppose I will show you. So this is what my memory. It have 32-bit size. 32-bit size means how many locations will be there? Total 2 power 32 number of locations will be there. So 2 power 32 number of locations memory got created. But in this 2 power 32 number of locations, if you do randomization, you will get some random value, like maybe you get some zero value or some 2 power something, a big value will generate. Okay, but in real time, do we use all 2 power 32 values? No, maybe we can store within 0 to 100 number of locations. We no need to store in 2, 3, 4, 5, 6 number. That much of range doesn't need it. Okay, maybe 0 to 100 or within 500 number of locations we may use, or 10,000 number of locations we may use. And that too in 0 to 100 number of locations also, maybe in multiples of 3 locations we may store, or only in an odd number of addresses we can store, or even number of addresses we can store. So there is a lot of changes, lot of configurability will be there, right? So all these things we cannot do in the Verilog. We can do, but they will not work efficiently. Okay. Before I have written multiples of 3 statement, right? To check that the multiples of 3, like that simple statements are there, we can use that. Okay, but it doesn't work much efficiently. But in System Verilog, we will write the constraints. Okay, by using the constraints, whatever the according to our specification, whatever the values you want to generate, same values we can write using the constraints, multiples of 3, or even 0 to 100 or 0 to 200, or even odd number of values or even number of values. Everything we can do using the constraint. Okay, so that is what the randomization. Everyone got clarity? Just work on today class. I will share you the recorded session today itself. Once again, go through the session. Okay, so tomorrow you can understand easily what are the advantages of System Verilog and disadvantage limitations of Verilog. You will get the clarity. Okay, any other doubts? And tomorrow I will share you the online test for Verilog. Till now, whatever the concepts we have completed, once again revise all the concepts and then attempt the test. Okay. Any doubts? Vinita, Sai, Lahari, and Manoj Kumar, Sumalata.
I have a small doubt, Prashanti. Yesterday's question, that full case and parallel case. Yeah, in the full case, it avoids the bad latch, and in parallel case, I didn't get the proper idea. I mean, in that, I mean, if we give the specific condition, it may not allow, or it takes parallel. I mean, parallel it will do all the statement,
Full case
all the
means
case conditions.
all, full case means all, say cases we write. Suppose 3-bit size
Yes,
means
even
8.
default also.
Every case we need to put. Parallel case means we put the question mark, so automatically generate the parallel scenarios.
Okay.
Case Z is nothing but full case. Normal, I mean, case Z is the parallel case. Full case means normal case.
Normal case, yes.
Hmm.
Automatically
Anyone
it
try?
generates the conditions, right?
Hmm.
That means, yeah. Okay, thank you.
According to what expressions you are writing.
Yes.
Others, did you try latches generate block swapping operation using a blocking and non-blocking assignment? Okay, try to complete Verilog soon. If you don't complete, again system Verilog is going to start. Okay, any doubts from Lahari, Sai?
No, ma'am.
Okay, okay then, thank you all. Bye.
Thank you.